morning, scholars. I hope you're doing well. I'm missing y'all a little extra today, so you're all in my thoughts, and I really can't wait to see you later. So this is the concept development for math for Wednesday, and it's actually kind of a long concept, so I'm going to split it into two parts, all right? So what we're going to do is we're going to read this story, we're going to talk about it, we're going to figure out first how to solve part A and then how to solve part B. Part B will be a separate video, all right? And please do come to office hours if you're concerned about any of it, if you're confused about any of it, because it is a hard concept. Don't freak out if you don't understand it. And please let me know, right? Because that's what we're here for. All right, so let's get started, okay? So today we're learning about Fred. He's an artist, and he cut a 9 3/4 inch square of construction paper for an art project. He cut a square from the edge of the big rectangle whose sides measure 3 1/4 inch. See picture below. So what is the area? The first question we're answering is what is the area of the smaller square that Fred cut? So I don't know if you noticed, but we've been talking about rectangles a lot recently, right? And a square is, and well, one thing we've been saying, before I get to that, one thing we've been saying about rectangles is a rectangle, its opposite sides will always be equal, right? So the green side will always be the same length as the green side, or green side will always be, that's not a good one. Here we go, let's try it. Take two. Green side will always be the same length as the green side, right? There we go. And the, let's go, blue side will always be the same length as the blue side. A square is a special type of rectangle where all the sides are equal. So in this case, it's not that like I have a green side that's always the same as the green side. All of the sides will be equal. So if I know that this side, let's say, is 2 inches, then I don't just know that this side is 2 inches. I also know that this side and this side are 2 inches. So when I'm talking about a square, if I know one side, I know all the sides. So that's what makes a square special. It's a special type of rectangle. So in this case, Fred is doing an art project with a 9 3/4 inch square, okay? He cuts, and that's what we see here. Like, so that would be this. This is what he started with, right? From that square, it says he cuts a square from the edge of the big rectangle, which is still the big square, whose sides measure 3 1/4 inch. So now I know that, again, since he cut a square edge that's sides measure 3 1/4 inch, right? If this side, as it's showing me, measures 3 1/4 inch, I know that this side is also 3 1/4 inch. This side is 3 1/4 inch. And this side is 3 1/4 inch, right? And so the first question, part A, is asking me, well, what is the area of the smaller square that Fred cut? So I'm looking for the area of the smaller square. So let's look at the smaller square. Remember that area is length times width. Well, since I know that this one side is 3 1/4 inch and therefore all the sides are 3 1/4 inch, to find the area of the smaller square, I'm looking to do 3 1/4 times 3 1/4. So let's do that, shall we? So I'm going to do 3 1/4 times 3 1/4. 3 times 3, 3, 6, 9. 3 times 1/4, or 3 groups of 1/4, is 1/4 plus 1/4 plus 1/4 is 3/4. Same thing here, 3 times 1/4 will be 3/4. And finally, 1/4 times 1/4 will be 1/16. So now we need to add all of these up together in order to get the full area, right? So like I've done before, I'm actually just going to hold my whole number off to the side for now. I don't want to use that yet. And I want to add my, let's go with blue, my 3/4 plus 3/4 plus 1/16, right? I can add these together already because they already have the same denominator. So I'm going to keep my denominator to the same, and I need to add my numerators. 3 plus 3 is 6. So now all I've done is I've just added this one, and I got 6/4, right? So I'm going to take away my 3/4 because I used them. Now I have 6/4 plus 1/16. So if I'm doing 6/4 plus 1/16, now I don't have the same denominator, so I need to give them the same denominator. Remember, what I'm going to do is I'm going to say, okay, what do both of these have in common, right? So remember, denominator is how much I cut it into. So if I have something that's cut into fourths, how can I make it so that it's now cut into something that's 16ths? Well, I'm thinking I can go 4, 8, 12, 16. So I'd have to make 4 cuts, right? So I'm going to multiply it by 4. And remember, if I multiply the bottom by 4, I'm also multiplying the top by 4. So now I have 16 on the bottom, and 4 times 6 on top is 24. Add my 1/16, which I didn't need to change because it already had a denominator I could use. Keep my denominators the same. 16, 25/16. So now I've also used this. Now if you'll notice, this is bigger than 1 whole. And I'm actually gonna, because we're gonna do B in a separate video, I'm gonna go ahead and take this part out, and I'm gonna just move my 25/16 to here. And I'm gonna separate out 25/16 into 16/16 and 9/16. That was what would be left over. 16/16 I'm going to turn into 1 whole, and 9/16 I'm going to leave 9/16. So now what do I have? I have 1. What do I have that I still need to use, right? I've got 1, 9/16, and then the 9 from earlier. So now I need to add all of those up together. 9 plus 1 plus 9/16. My area is going to be 10 and 9/16. And that is how I'm going to find the area of the smaller square. All right, so that's part A. Part B we're going to come back to in a separate video, just because I don't want us to get really confused, and I want us to be able to sort of break this down. Like I said, it's a big concept, so make sure you understand what we did for part A, and then when you're ready, go on to part B. I'll see you later, scholars. Bye.